Hey guys, welcome to the homestead. So I have this exciting series I've been kind of percolating on and planning to give for you guys. I don't know if we want to call it EMP preparedness or SHTF, what we're really talking about here necessarily, but my goal was to give you some oversight on EMPs, surges, lightning, solar flares versus nuclear EMPs, and some of the products on the market that I'm familiar with or not familiar with but going to get familiar with, and how they advertise themselves versus what they really are. So part one, which is what we're doing today, is I kind of wanted to give you an overview of what we're trying to protect against and what the possibilities are, what happens when there is a nuclear EMP versus a solar flare, like I think it was the Carrington event way back when all the telegraph wires and the keys caught on fire from the solar flare. And some of the products we're going to evaluate, and in part two we'll actually set up. I got some cool ideas using a pretty hot charge control, pretty hot electric fencer. We're going to try blowing up some products. We're going to try showing you how the products react in a voltage way on these, and then we're going to tear some products apart and show you what's inside of them. So to get to the first stage though, what we're really talking about here is with any of these protection devices, the Midnite SPD, the EMP Shield, or the Delta lightning arrestor, we're talking about suppressing surges. And when I say surge, I don't mean like, an extra 10% on your utility grid. So your AC comes into your house at 120, 240, plus or minus 10-ish percent, right? It might be 220, might be 250, but it's in that ballpark. What we're really talking about here is if that goes to say a couple thousand volts. One thing to remember is that products are always tested to 2,000 to 3,000 volts when they get listed. A few volts isn't going to kill that product, but a lot of volts will. And what these devices all try to do in various ways is they try to take an excess voltage on this wire, be it the red wire or the black wire, and they try to shunt it to the ground. So if the red wire goes to 2,000 volts, it will try to pass that to this ground wire and clamp everything at the same potential. And the thing to remember with that is that it's not the voltage that kills the product, it's a differential internally on the product. So if we have a device, and I don't have a device here, but I'll use this device. If we have a device like this cell phone, and we put it in an enclosed package so there's no grounding or anything, and we feed every connection on it 5,000 volts, as long as everything's got 5,000 volts, the device has zero potential. It wouldn't damage the device. But now if we take one, like the earphone ground and hook it to the ground, and then we take the earphone positive and we feed it 5,000 volts, it's going to fry every time. So what we're trying to do with all these devices is not necessarily get rid of all of the energy to ground as much as bring the potential consistent across the board. This building we're in here, this 10 by 10 building, for example, it's 50 feet away from our electrical panel. If lightning was to strike the electrical panel, it's going to run out here in the AC wiring, and the goal is to keep everything, the same. So now you may measure 4,000 volts in my electrical panel to ground, but if my surge arrestors do their job and keep everything clamped together, everything comes up with it. So the fridge that's, behind you guys there that you can't see, or this freezer, will not see 5,000 or 4,000 volts from hot to neutral. It will see, no voltage between those two, and the whole freezer will see like 5,000 volts. So that's kind of the concept of surge arrestors, if you will. We'll go more into that as we go into the products, but what I really want to talk about today was the different types of surges. You might see a nearby lightning strike. Lightning strikes your neighbor's house, induces into the ground a piece of wire, like this piece of wire. Forget about the surge arrest here. This piece of wire is an antenna. If your neighbor's house gets hit by lightning, every piece of wire in your house, in your ground, in your ceiling, in your walls, becomes an antenna, and it picks up the pulse from that lightning strike, that electrical pulse. And you would actually measure, like if you was to lay a piece of Romex out on the ground, say 100 feet long, and you twist all the wires together on one end, and you just put a voltmeter between two wires over here. Not that I recommend doing this during a lightning storm. This seems really dangerous. But if you were to do that, and you got a near, really close by lightning strike, you'd measure some pretty impressive voltage between those wires on this end. So that's one type of surge, is from a nearby lightning strike or a direct lightning strike. Direct lightning strike, kind of all bets are off. Any one of these products can help, obviously. I mean, anything is better than nothing, but it's going to be pretty amazing if you take a direct lightning strike. The other one is utility surges. I've seen many issues with utilities. We had one up in Maine, for example, where there was a 3-phase line going down the road, and I forget the primary voltage on the pole now, but whatever it is doesn't really matter. One phase coming out of that plant went to a multiple of 10. So if you were on that phase, instead of getting 120, 240 into your house, you're getting 1200, 2400 into your house. And all sorts of interesting stuff happened because these things aren't designed to have 2400 volts or 1200 volts from L1 to neutral. Now, if you'd have had a lightning arrestor, surge suppressor on that system, it would have clamped those two together and probably blown the main breaker before any damage happened to the house. If you didn't have one, your house probably caught on fire. So that's another type of surge that you're going to see, squirrel and transformer, substation type thing. And then the third one, which is really the one that I want to focus on for the purpose of these testings, specifically because one of these companies calls themselves EMP Shield. So they are actually advertising they'll protect against an EMP. So we have two types of EMPs, if you will. EMP stands for Electro Magnetic Pulse, and it could happen from a solar flare. So you've heard of solar flares where the sun shoots out pukes out a whole bunch of energy, and if it's facing the Earth at the time, that hits the Earth's atmosphere, and that can, if it's strong enough, can actually wipe out everything electronic. There's some speculation on what will survive, what won't. Most of your newer vehicles are pretty hardened already. The computers are under the hood. They're in, metal cases. They're pretty robust. But the real one that everybody asks about all the time is a nuclear EMP. So if you're familiar with that, great. If you're not, I'm going to have just a little tangent here where what a nuclear EMP is, or let me back up one more step. When a nuclear bomb is detonated, you'll see that kind of shock wave come out of it. And in that shock wave is an electrical pulse, a whole bunch of energy, tons and tons of energy. So nuclear EMP would be detonated above us in the air, such that we wouldn't have the nuclear fallout from it, but we would have that pulse. So if one of our adversaries decided they didn't want us in the modern ages, for example, they could shoot off a nuclear bomb miles in the sky. And I'm not going to go into details on the actual specifics of the EMP. There's tons and tons and tons of websites out there you can read on that. I want to talk more about how it works. So they can shoot that off up in the sky, and that pulse will run across the U.S. and will wipe out a whole bunch of stuff. Now again, remembering that a wire is an antenna, if you're off-grid and your longest wire run is from your PV array down into your cabin and all your equipment's right there's no utility lines, nothing, you've got a lot smaller antenna. If you're like we are here in Florida, you're connected to utility grid, we got a massive antenna. So with that in mind, I want to turn my map, and with a solar flare, it's a pretty slow moving thing. Any one of these devices has a lot of potential to save you from that. It's a very, I say slow, it's actually really fast, but it's happening in like probably half a second or something like that, the speed that it's moving. So these things have time to react. The nuclear blast, however, has about 3 different stages to it. If, let's say, just for the sake of picking on Hutchinson in Kansas, because they're on my map here, if the nuclear blast is put off directly over that, you're going to have this circle around that, probably reaching out to Kentucky and Colorado, maybe, a fairly large circle of that first blast. It's super fast. It's happening so fast that devices like this cannot react quick enough to save you from that. Especially if you're connected to the utility lines and everything else, like I talked about. And then there's another wave a little farther out, and then there's a third wave that's even slower than that. So you can kind of see where that first wave is just instant, like in nanoseconds, just bang, done. The second wave is going to take, milliseconds, and these devices can all react in that time. And the third wave is, out into probably even a little bit more than that, and they're all going to work for that. So a lot of it's going to depend on where that was targeted, or if there was multiple targets. And again, thinking about how your system is set up. If you're off-grid in a cabin and you're down here in, like Midland, Texas, and you have no wires coming from, 100 foot away from a generator shed, stuff like that, you've really designed your system with very short antennas, you probably, might have a very good chance of surviving that if you use one of these products. If you're in Wichita, you're probably screwed. Probably doesn't matter what you have for a device. That energy in that nuclear blast is such that, you know, it's going to probably get through any of these devices. Although these guys make some pretty lofty claims, but we'll tear one of them apart and take a look. So it's really going to depend on that and how your system is set up. So the surge arrestors, which is what we want to concentrate on in this video, are, you know, what you're going to do to best prepare yourself, where to put them, what ones to use. We have opinions. Everybody has opinions. There's a vast difference in price in these. These guys probably run 50, 60 bucks on the street. These guys probably run about 100 bucks on the street. These guys run about $400 on the street. And there's a lot of other varieties of stuff. I only picked one standard surge arrestor, which is the Midnite Solar SPD. I picked that mostly because it uses metal oxide varistors in there, MOVs, which is a pretty common type of surge arrestor. So if you pick a Cytel or one of those other brands, a Square D or something like that, this is what's going to be inside it. They're all going to be roughly the same. So I picked that, so I'd have that. I picked the Delta mostly because I'm going to show you guys the snake oil that is, you know, Delta lightning arrestors in my opinion. And then I picked the EMP Shield because these guys really set themselves apart by actually claiming that they will protect you from a nuclear blast. They'll protect anything. You can buy one of these for your lawnmower in theory. One of the things I don't agree with these guys is, like, when they talk about protecting your portable generator, for example. Now realize that your portable generator is this head full of copper wires and an armature that spins inside it that makes electrical power, 120, 240, like you use in your house. The way they protect a generator, at least from my reading on their website, is they put one of these on the battery, on the starter battery of the generator. So if you know anything about a portable generator with handles and wheels, the starter and the battery are kind of their own little 12-volt circuit. The generator head is over there making the 120, 240. So I don't see how one of these could protect the 120, 240 from the 12-volt battery. So anybody that's got any experience with these, I'd love to hear it down in the comments, but I'm really excited to tear one of these apart and show you guys on video what's inside it. But yeah, that's kind of where we want to go with this series. We want to tell you a little bit more about, you know, how these products work, where you'd want to put them, and, you know, today's video is mostly just to introduce you to the series, explain what an EMP is, explain, like, if, you know, if they target Washington, D.C. up in here, for example, you know, we may be okay down here in Florida, maybe. And it depends on the size of the nuclear blast. Oh, get caught up in my antennas here. There's a lot of variables to that too, and how far that goes. There's a couple different shows you can watch. One of them was Jericho, I think, was one of my favorites. It really did a good job of kind of showing what, you know, some terrorist organization or third world country or your own government, if you watch that show, can do to you. And they had strategically placed EMPs. So they sort of was able to wipe out the whole U.S. with, you know, that blast. Well, multiple blasts. So that's really, to me, is where, you know, I get a lot of calls, I get a lot of questions about nuclear EMPs, especially now with Russia pounding their chest and, you know, China and everything, and the threat of Taiwan and Ukraine invasions. There's just a lot of unrest in the world right now. And that's one thing that could be done pretty quickly, you know, to debilitate all of us. That being said, there's a lot of things that you can do to better your system, better your life, better your, you know, house, vehicles, whatever it may be. Like I said, the big thing is antennas. The other thing is, you know, have an old vehicle. You know, there's a reason we drive a 1994 Dodge pickup with the Cummins diesel and a standard transmission. You know, they drop that blast and we're screwed down here in Florida. We'll just tie the fuel line open and we'll push it downhill and pop the clutch. It's still going to run. Granted, you're only going to be able to get diesel for so long, and the tank's going to be dry, and yada, yada, yada. But there's all these things you can do to kind of better prepare yourself. If your main primary concern, of course, is SHTF, or, you know, the end of the world, whatever you want to call that acronym, there's a lot more that you can do. I would really advise towards starting to learn to live on a limited power budget or no power budget. Redundancy, stuff like that, you know, hand pump for your water, or a creek you can go get water in, things like that. It's kind of foolish, I think, to kind of plan on a solar system that will survive an EMP no matter what. there are things you can do, and we'll talk about that when we get into, you know, those stages. So I'm going to wrap this one up because I've already been jabbering for 15 minutes, but I kind of wanted to go into a little bit about what an EMP was, encourage you to do your own research on a nuclear EMP and the different, you know, blast waves of that. And then we'll bring you back here shortly, and we're going to talk about where to put the products, how the products work, and in our next video we'll go ahead and get hooked up and show you the clamping power of each one. We'll probably tear some stuff apart, and then we're going to see if we can blow some stuff up. So thanks for watching part 1, and we hope to see you back in part 2 really soon.